we are trying to find f of x, the derivative of this, right? But we know that the actual function is equal to this x to the power of 3 minus x squared. Okay, so this is a really simple question. We're just going to differentiate it. And that's pretty easy. So differentiate it, we bring the 3 down the bottom, and then we make it 3 minus 1. And the same goes for here. That 2 comes down the bottom, and it's a 2 minus 1. So that way we can say f of x is equal to this. And simplifying it all out, we get 3x squared minus 2x. That's the first part. Really simple, 1 mark. We can move on with our lives. Now, the next part for part B is that they want us to simplify this integral from 0 to this weird looking p. Okay, so that's strange. We can't really, we can go through and find the integral, but they're wanting us to use the fundamental theorem of calculus. Okay, so what happens is it's the derivative and we're integrating it. So it goes back to being the original value. But this time it's a definite integral. So you substitute the value that you've gotten at the top, that p, and then minus it on the other side by that 0. So let's see what I mean. So we know it originally goes back to being the original value, that x to the power of 3 minus by x squared, okay? And it goes like this. Okay, so now substituting that value, that p value in there, and then putting that 0 value in the minus side. So what we'll get is rho, or p to the power of 3 minus rho to the power of 2, and then minus by 0 to the power of 3 minus 0 to the power of 2. Okay, and so once we've done that, you can see that all of that cancels out to 0, and the final answer is going to be just rho to the power of 3 and rho to the power of 2. That's it. So you don't actually need to integrate it again. It just goes back to being the original value, and that's the fundamental theorem of calculus. So let's get on to part C, and that is we've got this funky expression, okay, from 1 to 3 dt. So we are trying to find the derivative of it. Okay, so because we're integrating it, and this is we're trying to find the derivative value, we know that that's going to be this t to the power of 3 business. Okay, and so what we can do is substitute in that value of x, right? Because it becomes basically the same thing, just that t to the power of 3, but this time we substitute in that value of x. And that minus 1, right? If we go through and we integrate it, we get the two brackets. I'll just find the integral first. So if we go ahead and we integrate it, then we get like t to the power of 4 divided by 4 from x to 1. And then we decide to differentiate it. If you notice, there's the one component of it, which is the x, right? And then there's this other component, which is a constant. And so when you find the gradient of a constant, right, what's the gradient of a flat line? Well, it's 0, so it cancels out. So when we try and find the derivative of the whole thing, just ignore that constant value of 1. And so it becomes back to being x to the 3. Now you don't have to worry about the minus sign. If the x was down the bottom, so if we had an x down the bottom there, then we'd have to stick a minus sign out the front because it would be that term. So hopefully that makes sense. Now we move on to part D. Okay. Now, this is asking us to find the derivative of another funky function. So our original function is 3x, and it's this cos 2y dy. Okay, and then we're trying to find the derivative with respect to x. So hopefully you can see that's what happens there. So using the same thing as before, we can see that the constant doesn't matter. All right, the constant of that 1, it doesn't do anything. When we differentiate it, it goes to 0. So basically what we can do is write out the whole thing here about that cos starts up with being cos, and then whenever we see a y, we're going to substitute 3x in there. Okay? But now it's a function within a function. So we're going to have to differentiate this value that we found, this value of cos 6x. Okay? And it's, I guess the thing that we're differentiating here, sorry, is that um, that 3, that additional 3 that's appeared. So if we find the derivative of 3x, that will be equal to 3. And so what we can do here is multiply this value by 3, and this gives us our final result, which is that all of this is going to be 3 cos 6x. Okay? And that's going back to this original one back in part C about cancelling out the constant. Okay? So hopefully that makes sense. If there's any questions, I'd love to hear from you. Love to help.